Implementing disaster recovery. All right, a very important topic here, disaster recovery, because what we're talking about is our data and protecting our data. And our data is very, very valuable, of course. We all know this. But something at some time or another is going to happen to our data. Something bad is going to happen to it. That's just the way it is. It's the reality of being a database administrator, is the fact that we're going to have disaster recovery plans. So, with that being said, this whole video is pretty much going to focus on backup and restoring, backup and recovery, because these are really the only means we have of keeping our data highly available and minimizing data loss by having a pretty sound backup and recovery plan. So that's what we're focusing on here, backup and recovery. Now, what we mean by disaster recovery, a disaster could come in a wide variety of misfortunes. For instance, we could have hardware failures. And before we get into our outline here, just to mention this, there's something out there called the MTBF. And you hardware guys will know this. The MTBF means the mean time between failure. And pretty much it's just one of those law of averages, basically saying that every 40,000 hours, something bad is going to happen to your hardware. A hard drive is going to crash, for instance. So, with that being said, there's a couple of other things that could happen, such as natural disasters, hurricanes, tornadoes, floods, fires. They all happen. Earthquakes, they're going to happen. Of course, depending on where you are, will depend on which disaster could happen, but they're going to happen. Also, we could have malicious users, hackers. So, disgruntled employees, things like that. So the whole point here is that disasters are going to happen. I think I've pretty much made that point abundantly clear. And the fact is we need a good backup and recovery process. So we're going to cover all of that in this video. We're going to start off with an introduction to backup and recovery. I'll take you through all the different backup types that we can do and methods that we can use and strategies we can implement inside of our backup area here. We'll move into recovery and restore as I'll talk about pretty much all the different ways that we can restore our database. Some pretty cool stuff in here. Also, we'll get into some demos. We'll go through and we'll learn how to use all the different backup types, full backups, differential backups, transaction log backups, you name it, we'll do it. And we'll also go through all different ways to restoring databases. We'll go through point-in-time restores, piecemeal restores, and just your standard restores. So a big video here, a big important video on disaster recovery. Also, there isn't really many new features in SQL 2005. If you're familiar with backup and recovery in SQL 2000, it's pretty much the same other than how you do it. Of course, the interface has completely been restructured in SQL 2005, so even though you may know how to do it in SQL 2000, believe me, it's a lot different just navigating the interfaces to do it. So this video will still come in very handy to you. There is a couple of small upgrades to the restoring process that I'll talk about when we get there. So let's jump right into an introduction to backup and recovery here. And the first thing I want to do is just take a high-level look at what makes up a database underneath the hood. Because I think getting an understanding of all the different components that make up our database is really going to help understand how the backup and restore process work. So let's do that. And the reason I say high-level here is because we're going to take a low-level look, a very detailed look at how all this stuff works in a future video called Creating Databases. But for now, again, this high-level overview here, we have our database. Underneath our database, on the physical file system inside a SQL Server, we have something called data files, right? And these data files have the extension .mdf. We also have something called the transaction log, and the transaction log has an extension .ldf. Now, the purpose of the transaction log is basically our frontline defense for our data files. Every single thing that goes through this transaction log, every data modification, every update statement, insert statement, or even a transaction itself is logged inside of our transaction log because inserts and updates, they are what is called a logged operation. So everything gets logged inside of our transaction log, and each record inside of this transaction log has what's called an LSN, a log sequence number. And that's literally all the log is one big running list of all of these actions that have been performed in our database. All the SQL statements themselves trapped inside of this log file sequentially. And of course a timestamp next to it as well. So after it goes through the log, they get committed into our actual data files. Now another note about data files, you can actually have secondary files as well in here, and multiple secondary files, and these are going to have this extension NDF. So we would have two NDFs here. And then you can even have something called a file group. And a file group is just a kind of a logical way to structure our actual files themselves. So how this would work then is this would be up here, this would be our primary file group. And down here, this would be our secondary file group. And then what we could do is we could put these file groups on separate physical disks, which is a pretty common technique out there for a performance game. And then what we would do is then we actually have control over where we want to place these objects. We can put tables on one file group, our indexes on another file group. Again, put those on separate physical disks, and boom, we have ourselves a very nice performance game. But again, everything that happens outside has to go through this transaction log before it goes into our data files. So the reason this happens is, of course, for protection. For protection, if anything ever gets corrupted in here, that's okay. It's stored in our transaction log, and we can go back and get it. But again, why am I telling you all this? Well, because again, it's very important in understanding how backups work, because all the little things that can happen in between here and how this transaction log works, and even if it's even relevant to our situation, all depends on the type of backup and the type of recovery model that we choose, and also the type of restore that you end up doing. So going through some of those recovery models here. Now, before I jump into the recovery models, what is a recovery model? Well, a recovery model just basically governs how this transaction log works. And in turn, that's going to determine what types of backups we can perform on our database. So, starting with the simple recovery model, the simple recovery model means just that. Very simple to manage and maintain because it takes the transaction log right out of play. Basically, what happens is every time you do a full or a differential backup, or any time that transactions are committed, and basically committed means they're written from the transaction log to the actual data files on disk, the transaction log is going to get truncated. Truncated means, of course, emptied. It's going to get emptied out. So that makes transaction log backups irrelevant, and you will not be able to perform them under the simple recovery model. And what does that mean? Well, that basically means that you'll never be able to do a point-in-time restore. So you will experience data loss under this model if you're not backing up every night, and even if you are backing up every night, if you have something happens at 6 o'clock during the day and you back up every night at midnight, well, you lost all that day's worth of data. So simple recovery model, just that simple, purely because you can only do the two basic types of backups and you cannot do point-in-time restores. The full model, on the other hand, is just the opposite. It supports everything. All backups are supported, the transaction log functions normally, and everything is logged from pretty much, and what I mean by logged, a logged operation, as I said before, is your inserts, your updates, your bulk insert statements, everything. Everything that goes through this database is a logged operation. The bulk logged model, on the other hand, is basically used for when you're bulk loading data. So the bulk insert statement, for instance, that allows us, and I'm going to actually use this here in a demo, but this allows us to take a text file. Say we have a text file filled with a bunch of data. Well, we can take that text file and run it through a bulk insert statement, and that'll load up the data into a table for us. Well, under the bulk logged model, basically what it'll do is we can flip to this when we do those operations if we do not want to fill up the transaction log. Because under the full model, if we do a bulk log operation, it's going to log every single one of those statements. So if you're loading hundreds of thousands of records into a database, yeah, your log file is going to get really big really quick. So what a lot of people do is they'll switch to the bulk logged model, run all their data loading bulk insert statements to get data loaded in there, and by running it under this model, it will not log every single operation inside of the transaction log. It'll minimally log operations, only the important ones, such as your index creation statements and things like that, the important ones. So looking at our different backup types here, we have a full backup. And a full backup is, of course, going to be the one that takes a very long time to do because it's backing up everything. Every file group, every data page, every data file, every table, every record, everything in the transaction log, everything inside of a full backup gets backed up. Differential backup is going to be the one that pretty much backs up everything that's happened in your database since your last full backup. So if I do a full backup on Monday and a differential backup on Tuesday, it's going to hold all of my changes that have happened to the database since Monday. Also, if we do a differential backup on Wednesday, it's going to hold all of my changes since Monday. So that's right, not since the last differential backup, since the last full backup. So no matter how many differential backups you do after your full backup, it's always going to hold all the changes since your last full backup. Transaction log backup, again, it's going to take everything in that transaction log, back it up, and then truncate the log. And this is the only backup type that is going to truncate the log. Now, there are things we can do if we don't use transaction log backups to keep our transaction log lean, clean, and mean by truncating it ourselves. And I'll talk about that when we get into the full backup, because I've seen a lot of people out there have just massive transaction logs that really can bog down the system. And it's good to keep this thing lean, mean, and clean just for performance reasons. But we'll talk about that when we get there. We also have file group backups. File group backups just simply allow us to back up individual files and file groups within our database. And we would use this for VLDBs, very large databases, because when you're talking about backing up terabyte, exabyte, petabyte size databases, full backups and differentials just might not cut it by themselves. You're going to need a better means of backing up just individual file groups and files. Again, just for time reasons, because there's not enough time in a day to do a full backup or even differential backups every night when you're talking about a database of that size. So now that we have a good understanding of the backup types available to us, let's talk about some backup strategies and how we can use these backup types in conjunction with one another to form a backup strategy. And there's lots of different strategies out there. I'm going to go through the most commonly used ones out there in the database world. And these are all well proven and used, and they cover pretty much everything, all four of these different types. And really, I'm going to start at full only over here. Full only is good for simply the small databases, those databases that aren't mission critical, that you know, if you do suffer some data loss from a catastrophic event, you can recover from it. And it's no big deal if you lose some data. The couple of disadvantages to full only: slower backups. Simply because you're always backing up everything in your database, it's going to be a little bit slower. Another disadvantage is the transaction log is never truncated. And in fact, this can be a dangerous thing, because if your transaction log isn't set to grow automatically, then it could fill up to 100%, in which case that would lock out your users. So we don't want that happening, and there's a couple of strategies you can actually use with the full only model to make sure that never happens, and I'll talk about that here shortly. Also, we have faster restores, and the reason this is actually the fastest restore, because you're only always restoring from one file, the full database backup, where if you're doing full and differential, you got to restore your fulls and then any differential since the full. Transaction logs, same thing, you got to restore all those transaction logs since the full, and those are timely processes, where the full only, again, it's always just restoring one file, so it's relatively quick. Now, a visual on this, how would this work? Well, if we were doing full backups and we had a small database that wasn't mission critical, not a lot of transactions going into this on a daily basis, then we could do a full backup every other day. Again, the downside to this is, you know, say we have a crash down here at Thursday night at some point, right before our backup at midnight. Well, guess what? If there was any data entered in between these points, we would lose it, because we'd always, of course, have to restore from our Wednesday backup. So that's the downside. The upside to full-only strategies, of course, it's easy to manage, because we only have one backup always pretty much available that we can restore from. It's just easy to manage one file, makes the restore process a lot easier as well. Full plus differential, on the other hand, this is good for medium to large databases. We have fast backup simply because when we use differentials, we're only backing up the changes since the last full backup. So that makes for some speedy backups. Also, just like full, these are the only two strategies here, full and differential, that we have to worry about the transaction log filling up. So transaction log will not get truncated under this model in this strategy. So we'll talk about that here again shortly, as I was mentioning. And also, the restores are slower, and that is because we have more files to restore. We're going to have to, for instance, if something crashes, we're going to have to restore our full backup and then any differentials after the full up to the point of the crash. And to give you a visual on that, let's say we do a full backup every Monday, and then we do a differential backup on Tuesday, Wednesday, and Thursday. Well, this is how this will work. If there's a lot of changes in here from Friday to Tuesday, then we'll have some data in here, some differential data. Say there's more changes from Tuesday to Wednesday. Our backup on Wednesday will hold even more data, because it'll hold all the changes from Tuesday and everything that has changed on Wednesday. Same with Thursday. Thursdays will just keep getting bigger, and this happens because, again, differentials always hold the differential data since the last full backup. So these will just keep getting bigger until we hit another full backup, and then this differential will only hold the changes from Friday. So if something happens here again Thursday night, something crashes before our full backup, well, we'd have to restore that full, then each differential sequentially to get to the point where we need to be. Now, a couple of things I want to note about the transaction log here. The first thing I want to talk about is how you can actually still use that transaction log to recover this data between our last differential backup and the point of our crash. Same with over here. We can do this in the full strategy too. We can attempt to recover all of this data if there was transactions that have occurred since our last backups. Now, keep in mind this will only work under the full recovery model because, again, the transaction log, it'll just keep getting truncated under that simple log, and you can't do transaction log backups anyway under the simple model. So what I'm talking about here will only work under the full recovery model. And what administrators will do is as soon as something crashes, they'll immediately take a transaction log backup once I get SQL Server back online, because that transaction log will have all of the transactions since our last backup, whether it was a differential or a full. So what you can do is you can quickly do one of those transaction log backups, and a lot of people will do this using the no truncate clause, because that'll basically leave the transaction log alone, and then it'll just simply do a quick backup so we can have all those transactions, and then we can restore all of this data that we lost before the crash occurred. So that's how you can get data back if you're not using transaction log backups and you're under the full model. Now, to keep these transaction logs nice and tidy, what a lot of people will do too, and again, this will also only work under the full recovery model, is say you're only using the full backup strategy, but you want to keep your transaction log truncated. There's actually two things you can do. One is there's an option at the database level called truncate log on checkpoint. If you turn this on, basically what a checkpoint is anytime SQL Server writes data from the transaction log to the data files, that's a checkpoint. And you can turn that option on, and every time it does that, it'll automatically truncate the log. And that's not the cleanest way to do it. In fact, it's a performance decrease simply because SQL Server will have to truncate the log every single time it writes something from the log to the data files. But there's another thing you can do, and that is to quickly do a transaction log backup scheduled right after your full backup, only this time you would use the truncate only clause. And the truncate only clause, again, will do nothing but clear out that transaction log backup right after your full backup. So that's a good option to keep your transaction logs nice and clean. You could also do that after a differential, but that may be dangerous if you want to recover up to the point of failure after a differential, and smart to do only after full backups. But again, you have to be under the full recovery model to do that. I like to stress that simply because if you do leave it at the default, the simple recovery model, then you can't do this. And it's good to keep those transaction logs clean. Now, we also have full plus transaction log backup strategy, and this is good for pretty much any size database. You're going to see this model here, or this strategy, is a lot similar to our full plus differential. The big difference lies here in the fact that our transaction logs are automatically truncated for us. So this does not happen with transaction log backups. They're not cumulative. They don't hold the changes since the last full. They're always truncated after each log backup. So they always only hold the changes since the last log backup. And that's really the only difference between that and the differential. The other big advantage here is that we can recover to a point in time. Again, since a transaction log backup holds the sequential log of everything that's happened, we can pick exactly down to the millisecond where we basically want to restore up to. So to give you an example of this, say we do on Monday, we have a full backup. Every 4 hours during the day, we do a transaction log backup. And at night, we only do one at midnight because there's not a lot of activity at night. And then again, we repeat the process throughout the day. So say we had a crash here at Tuesday night, right around this point, we'd have to restore our full backup from Monday, and then each transaction log backup to the point of recovery. And then, of course, if we want to get to this point exactly, we'd have to do a quick transaction log backup once we get into the system. And then we could even pick this point in time, or a couple of seconds before this point in time, to get all of our transactions back. Now, on to our last one here, full plus differential plus transaction log backup. This is the best of all of these worlds. It's good for any size database, fast backups, fast restores, and also our transaction logs are kept nice and tidy. The only downside to this one is, of course, it's a little more difficult to manage because you do have so many files you're going to have to deal with when you go through the restore process. And how this works, let's say we do a full backup on Mondays, transaction log backups every 4 hours during the day, because the day, of course, we have the most activity. Differential at night, at midnight, and then that's pretty much how it goes. Every 4 hours, differential every 4 hours, until we reach Monday again, where we'll do another full backup. How this one will work, let's say we crash on Tuesday night, right before a differential backup. What we'd have to do is we'd first have to restore our full backup from Monday. Then we'd have to restore our differential backup from Tuesday. We'd ignore these logs because all of this data would be inside of this differential. And then each transaction log up to the point of recovery. And of course, if we wanted to recover to a specific point in time after this transaction log, we'd have to do a quick log backup once we got back onto the server to get those transactions. But the point is here, we have pretty much the best of all worlds. We have point-in-time recoveries. It really is the maximum point of recoverability with fast backups, fast restores, and transaction logs being truncated. So, the best of all worlds here, full plus differential plus transaction log. Another one that I want to mention is the file group backup. And the file group backup strategy is really meant for, it's an advanced topic. It's meant, again, for VLDB, so I just want to touch on it here. Very large database. Again, let's say we have a terabyte-sized database out there. We could do file group backups to really expedite the process of backing up. Since if you had a terabyte database, you're not going to be doing these full backups and even differential backups because they'll just have way too much data to back up. And what you can do, and most likely if you do have a very large database, you're going to have your file group split out on separate drives, separate physical drives to speed up performance of that very large database. But how the backup processes work, let's say we have a month view here where we have our first week here, we have our second week here, we have our third week here, and we have our fourth week here. And let's say we have 3 file groups inside of this database. Here's how it would work. We could do a full backup on the first of every month, right here. And then we could do transaction log backups every day throughout the days, throughout the week, until we get to our second week. And then at the beginning of every week, after the first week, we would do specific file group backups. So we'll do file group 1 this week, file group 2 this week, file group 3 this week. Again, with transaction log backups all over inside of these weeks. Now, the cool thing about this is new in SQL 2005, if you happen to be using the Enterprise Edition, file group restores are online operations, meaning you don't have to take the database down to do a file group restore. The downside, of course, is only that file group will be offline during the restore. So most likely you'll have your objects, certain tables split out in certain file groups. Those specific tables in that file group will not be available to you. And since you're doing transaction log backups in between here, you'll still have the maximum recoverability because you'll be able to still recover to any point in time. And you could do differentials in between here too. I'm just going to throw this in here for simplicity's sake. But again, I just want to mention that the file group backup strategy is there, and it is a very, very viable option for very, very large databases. Again, I just wanted to mention that. It is sort of an advanced topic, so I don't want to spend too much time on it. Now let's move on to the restore process and take a look at what's involved in restoring databases from our backups. And basically this is how it's going to work. Standard restores, these are things that are going to happen pretty much every time you do a restore. That's why I call them the standard restores. These first 2 options you're going to have to really pay attention to because you're going to have to do them every single time you do a restore. The first one is the no recovery option. You're going to have to use this option, and I'll show you in the actual interface. Very, very simple to do. But you're going to have to use this option when you have multiple backups to restore from. So if you're doing differential backups and transaction log backups and you have to restore from a full and then restore those transaction logs or differential, you're going to use the no recovery option up until the last backup, up until you're restoring from the last backup, because this is just signifying to SQL Server that you're not finished restoring quite yet, so don't let people into the database until we're done. So when you do get to that last backup, you're going to use the recovery option, and that's going to tell SQL Server to allow people in because you're done restoring. And this will put it back into the normal state for users to get in. So very, very common operations here, very simple to do. There's just a little option. You can only do one or the other when you actually do a restore, so we'll get into that when we get into the interface. Also, something that I want to mention that's very common that I see a lot of people do is move databases. Let's say you're restoring to a different server. You're moving it from one company to another, or you're taking it from the office home because you want to work on it at home. Well, because when SQL Server writes these backups, it actually writes the physical file paths in the header of the backup. It's going to try and restore these files to the same spot on disk as the backup, where the backup occurred. So, what will happen, of course, if you do that, if you do move to another physical computer where that path doesn't exist, SQL Server is going to throw some very, very funky message that you're not going to understand right away because it is so funky, and it's going to fail. So what you need to do is use the move option. if you're using T-SQL. If you're using the interface, you just simply specify in the data file path, and again, I'll show you where this is when we get into a demo. You just specify the new path. That's all, but you got to make sure you do this before you click OK to restore, otherwise it won't happen. So very easy to do. It's just people kind of forget this step. I even forget this step every now and then when I move in databases from the office to home. We also have point-in-time restores. So if you're using transaction log backups, we can specify that we want to restore up to a point in time. And this is pretty cool because we can use the stop at clause, and the interface, the actual SQL Management Studio interface is also very easy. We just simply click and choose what point in time we want to restore from in a certain transaction log, and boom, it'll take it to that time. Keep in mind though, if you do restore to a point in the transaction log, basically what's going to happen is anything after that point is going to be erased. So be careful and make sure the time you choose is really the time you choose. Also, there's another one called marking. You can restore to a marked transaction up to a point in a specific transaction, because what can happen is you can create marks. If you have long-running transactions, basically say you have a stored procedure that takes 20 minutes to run, and you're running multiple updates and insert statements inside of there. Well, what you can do is you can create you can encapsulate that stored procedure in a transaction and then put marking points after each one of those statements. So what this will allow you to do is, and this is kind of an advanced concept, but what it'll allow you to do is restore up to one of those marks inside of that transaction. So it's kind of cool. I just want to mention that and also show you how where you can do this in the interface. But again, it's kind of an advanced topic. I just wanted to briefly touch on it there. We also have piecemeal restores. And piecemeal restores are for our file group backups. So just like when we do a file group backup, we're really doing it as the staged approach because our database is so big. Piecemeal restores are just that. We're just doing a staged restore to get parts of our database back. And we can restore a primary file group and optionally any secondary file groups. The thing to note here is, of course, you can restore secondary file groups at any time as long as your primary file group is intact. And of course, those will be online operations. Another thing I want to mention about piecemeal restores and file group backups is that it kind of adds another level to the whole backup process, because you can do full file group backups and differential file group backups at the file group level. So that's why I'm saying it kind of adds another level in there. Also, transaction log backups, you do not have to do a file group transaction log backup. The nice thing about transaction logs is that SQL Server knows which transaction belongs to which file group. So if you happen to do a file group restore, you do a full file group restore, a differential file group restore, and then just a full-blown transaction log restore, SQL Server will pull the transactions that it needs out of that transaction log and put them into the appropriate file group. So that's all handled for us. Very nice. Alright, so those are our backup types and restore types. Let's take a look at how all this stuff works with a demo. So what I'm going to do here is jump on into SQL Server Management Studio by heading on down and start on over to Programs, SQL Server 2005, and SQL Server Management Studio. As soon as this opens up here, I'm just going to go ahead and click, go ahead and connect to our SQL 2005 dev instance. This is where we'll be doing our interface work. There's our dev instance, there's our production instance. Also, I'm going to open up a little script that I made, and this will give you something to look at while we do the interface side of things. We'll start with backup. I'm going to go ahead and cancel this so we're not connected to anything. And this is just kind of the backup script. I'll walk through the script when we're done with the interface side of things. And we're going to work with our AdventureWorks database. Now, the first thing you want to do is create a backup device. And I'll tell you why here shortly. First of all, the backup devices are stored inside of the Server Objects node under Backup Devices. So you can see there's none under here right now. To create a backup device is very simple. Just right-click on it, choose New Backup Device, and boom, we have a dialog box. And basically what this is going to ask us to do is give ourselves a device name here, and also a file. And I'm actually going to create 3 backup devices here really quick. And really what a backup device is it's just simply a permanent storage mechanism for our backups. So you can create, on-the-fly backups and choose a file name every time. This is good because it's always there. We create it once, and boom, we can always point to it. And if we need to do manual backups, of course, 90% of the time we're going to have these automated for us. But these are permanent backup devices that are going to contain all of our backups. So we'll give it the device name AdventureWorks Data. And I'm going to go ahead and hit the Browse button here. And we are going to browse to the C drive when it comes up. SQL Backups. So I made a little backups directory. Let's give it the file name awdata.bak. There we go. We click OK. We click OK. And now we have a backup device. I'm just going to go ahead and script these other two here. Two more backup devices, one for the log and one for file groups. So I'll hit execute. And you can see we're not connected here, so it's going to ask us to do a quick connect. Sure, why not? Quick connect. Run those backup devices. And you have to run these in the master database, you see, because they're at the server level. So now if we click refresh here, boom, we got it. And again, I'll walk through what this code does here once we get to the scripting section of this segment. But until then, boom, we have our backup devices available to us. Now we can start pointing backups to these devices. We have a device for data, device for file groups, and a device for transaction logs. Now, before we jump in and get right into these backups here, let's first take a look at the recovery model of our AdventureWorks database to make sure it fits with our backup strategy. So I'm going to go ahead and right-click on AdventureWorks and go to Properties and Options. And inside of the options here, you're going to see the recovery model by default is set to simple. And now what we're going to do is we're going to do pretty much the final backup strategy that we looked up, which is full, differential, and transaction log, so we can see how all the backups work. Well, simple, of course, is not going to work for that strategy. So we choose full, click OK, and boom, we're all set. Now we can do transaction log backups because we're under the full recovery model. Now, the first thing we're going to do here is a full backup. And a full backup is, of course, something we need to do no matter what to start with, so we have kind of a baseline backup, something to refer to that has everything. So we know our database is in a good state right now. Perfect time to do a full backup. So what we're going to do is right-click on our database, go down to Tasks, and on over to Backup. You'll be getting very familiar with this dialog box if you do backups manually, because it's pretty much what we're going to live in to do all of our backup types here. The first thing you're going to do is, of course, choose the database you want to back up. We can see the recovery model is in here, grayed out, just to tell you that, what recovery model you're using. And then your backup type. And of course, this recovery model is here just to show you if it's on simple, then transaction log will not be in here. You'll only have full and differential. So we're going to choose full as our backup type. What are we backing up? Of course, we're going to back up the entire database. There we are. Next, SQL Server gives our backup set a name. And this is pretty sufficient. It has a pretty good naming convention built into SQL Server here. So you can see AdventureWorks full database backup. We'll give it our own little description here. How about the dev instance? Full backup. There we go. We can also pretty much say that this backup set will expire after a certain amount of days or on a specific date, which means it's basically marking it for overwriting. So you can overwrite this backup set after that specific amount of time. And then importantly, very importantly, our destination. Where are we putting this? Well, this is where I'm saying you can just, specifically you can choose a disk here, and then you can just browse to a file, and that would be a temporary backup. Or we can click remove, and then add again, and then we can choose backup device, and then choose our backup device. And you can see all of our backup devices are in here. We're going to choose data, and choose OK. So it'll back it up to that device for us. Another cool thing you can do is you can actually span this to multiple backup devices. Kind of an advanced concept, but if you have very large databases, you might want to look into that because you can speed up the process of backing up. And then we have some options to look at here. The first one is our actual media set here, and this is where, again, you can overwrite the media. What we're going to do is, since this is the first backup in this media set, we're going to give it a name and a description. So we'll go ahead and give it the name here, AdventureWorks Media, and a media set description of AdventureWorks, how about backup media set? And again, the media set just pretty much gives it a name and a description on the media set, and if you do this, it'll erase any existing backups. That's why we're doing it the first time, as I said. Also, we have a reliability section here. If you want, you can check this to verify the backup when finished. That'll take a little longer to do, but it'll verify to the files, basically, to make sure they're not corrupt. And also, you can do a checksum, which is another redundancy check on the media itself to ensure everything looks good on the data side of things on that media. So this is all. We're all set. We can't choose any other options down here because, of course, we're not doing a transaction log backup, and we're not using a tape drive to do our backup. We're using the file system. So we're all set. We click on OK, and down here is your progress bar. Get used to this. It'll begin to look familiar, and you can also, of course, here's pretty much your cancel button to stop the backup. And that's going to take a minute or two here, so I'm going to go ahead and pause the video until we're done. And there we go. Backup of AdventureWorks completed successfully. We click on OK. And now, if we want, we can go to our backup device. You can right-click on it and choose Properties, or you can just double-click on it as well here. Don't pop it open. We can go to the media contents, and look at this. Here it is. Here's our media information, metadata about it, the media set itself, AdventureWorks Media. There's our description. And then, of course, all of our backups will be now stored in this device under this media set. So you have things like the name of the backup, that's the name that we gave it, or that SQL Server gave it, the type of backup, or the type of component that it was backed up on, the actual component, of course, a full backup. And then on down the line, the database, position, date size, so on and so forth, just more metadata about the backup itself. But the backup is completed successfully. We have our first full backup. Now, the next thing I want to do here is come down and we're going to do a bulk insert command here. We're going to load up our bug testing.testers table with a file that I have created that has lots and lots of data in it. So just to show you this file here quick, I'm just going to go to our C drive and into our SQL folder. And into our data folder, I have this file called testers.txt. And if we open this up, you can see it's just a 3 columns, comma delimited. And there's tons of data in here. I think I have 20,000, close to 20,000 names in here of testers. So what we're going to do here is we're going to use the bulk insert statement to load up that file saying the field terminator is a comma and throw that data sequentially into bug testing.testers. But before we do that, let's go ahead and right click on our database again and go to the properties, and we're going to change the recovery model here to bulk logged. And the reason we're doing this is because we don't need to log this operation. We don't need to unnecessarily fill up our transaction log, because so what, if this operation goes bad, guess what, we have the data right here anyway, so we can just truncate the table and try again. So I'm going to go ahead and highlight this and hit execute, and that's going to go ahead and load up our bug testing.testers table with 19,000 plus rows. So I'm going to go ahead and hide our results pane here. And then now we just have to go back into our AdventureWorks database properties here by right clicking on the database, choosing properties, going to options, and switching it back to full mode. So again, what that did is that just prevented our transaction log filling up with all of these statements. Of course, the bulk insert statement just completely was ignored by the transaction log. So good thing to do. The next thing we're going to do here is a differential backup. So what we're going to do is head back on over to our database, and instead of right-clicking on the database this time, you can also right-click on your device and choose Backup a Database. The difference is it doesn't automatically choose our database for us, but we can do that. We'll choose AdventureWorks here. That's the one we want to back up. What type of backup? Well, this time, a differential. We'll leave the name the same. This time we'll call this our dev instance diff backup. Contents are, excuse me, the destination is good. It held it from the last time we were in here. The only other thing I want to do here is go into options and just ensure that we're going to append this to the existing media set. We do not want to overwrite what was already there because we already initialized it with the correct media set name and description. So now, same thing, we just click OK here. And now you can see that was a lot faster than our full backup, a lot faster, because it only did the changes. Basically, it took all the data that we just loaded and backed up that data. So now if we go into our media set here, or excuse me, our backup device here, and I'm just going to double click on it, go to media contents, check it out. Now we have a full and a differential backup here. And a nice thing too, it also shows you the sizes. So you can see our full backup is a lot bigger than our differential backup. And boom, that's all there is to it. Now let's move on to transaction log backups. And here's how this one's going to work. What we're going to do is we have inside of the AdventureWorks database a table called humanresources.shift. I'm going to go ahead and right click on this table and choose open table. Look at the data inside here. We have 3 shifts, day, evening, and night, with their respective start and end times, and also the modified date of this record. So what we're going to do is we're going to insert 2 of our own records that, yeah, we want in there, and that is going to be these 2 right here, normal and nocturnal. The normal shift from 9 a.m. to 5 p.m., the nocturnal shift from 9 p.m. to 5 a.m., and then we're going to have another record in here called Hacksword. We'll say some hacker guy thought he was being a funny guy, and he came in and made a shift for 7 a.m. to 11 p.m. Ouch. So yeah, we'll say that shift wasn't intended to be there. Somebody did a SQL injection in our data and messed up our data. So we're going to recover to a point in time using the transaction log backup. So what we're going to do here, I'm going to go ahead and highlight these first 2 rows here, because again, we want these in here. These are the good rows. So there we are. They're in there, no problem. And now, let's put the bad row in there. So I'll hit execute, and boom. So now we have our data in here. Just to verify again, I'll right click on our table, choose open table, and there we go. Now we have our normal, nocturnal, and Hacksword with their respective modified dates and times in here. So Let's go ahead and do a transaction log backup. And how we can do this is very simple. Once again, let's go right into our backup device here. Right click on it, choose backup a database. And what database? Well, we know a database, AdventureWorks. Backup type, this time, transaction log. What are we going to do here? Let's go ahead and type in again dev instance for our description, translog backup. And this time also we do not want to back this up to our data device. We're actually going to, we made our own transaction log device. So I'll click on the add button, choose our device, and choose our log device here and click OK. Yep. Now if we go over to the options page here, we're going to do the same thing. Let's go ahead and call this our AdventureWorks media set. No, actually we'll call this our log media set. And then our description will be the same thing here. AdventureWorks log media backup set. And we have the same reliability choices. We also have our transaction log choices. And this is what I was talking about earlier when I talked about the truncate only and option when you want to do a full backup and you're in the and that's all you're doing is a full backup strategy. Well, you can use this to truncate the transaction log. Very handy. You can also do a backup of the tail log. And this is good again for when your database crashes. And you want to come back and you want to gain all those transactions that have happened since your last transaction log backup up to the point of the crash. This is what you'll do to get this, because what this does is it backs up what's called the tail of the log. Anything that's happened after a backup, after your last transaction log backup up to a point of a crash, that's called the tail log, otherwise known as the active log. So you'll want to do that if you're going to, of course, back up the tail log to grab those transactions. We're just going to, of course, do a standard transaction log backup that's also going to truncate the transaction log. So we're good here. Let's click on OK. You can see the transaction log backups are pretty quick too here, especially since there's not many transactions in here, just the ones that we just entered in there. And boom, we'll click OK. Now, one more type of backup here that before we get into restores and doing all these restores is, of course, the file group backup. So what I did here is, again, we have a device for our file groups. And what I want to show you is how the file groups are segmented out inside of this AdventureWorks database. What I did, if we go to the properties, is I made another file. I made a file called AdventureWorks_bug data. So let's say, for instance, that we want to put all of our bug tables and all of our, basically all the objects that are bug related, are bug tracking related, we want it to store on a separate file on a separate disk somewhere so it doesn't bog down our production data and really what the database is used for. So that's what I did. I made our own file here. And then I also, and you can see since it is a secondary file group, it has the NDF extension. And I also made a file group called bug data. And then what I did is I just associated this file with that file group. So there we go. Now we have another file with another file group. And then what we can do is just simply put our objects on that file group. So if we go to tables, and then our bug testing.testers table, I'm going to go into modify here. And as soon as this fires up, I'm just going to right click or click on this and go to view, properties window. Here we go. Here's the properties for our table. If we go ahead and drop down our data space specification, you can see right now it's attached to the primary file group. I'm going to choose the bug data file group. So now this table, once we save it here, I'm just going to go ahead and close out of it and choose yes to save it, is going to be attached to our secondary file group. Pretty cool, huh? Now we can do the actual physical file group backup here, so let's go ahead and head on back down to our backup devices. Right click on file groups, choose backup a database. We'll go ahead and choose AdventureWorks once again. We can choose a backup type, full or differential in this case. And you can see as soon as you choose one of these, we'll go ahead and do full. And then hit files and file groups. It's going to pop open what file groups do you want to back up. And we're going to go ahead and choose both of them here to back them up. When we restore them, we'll only restore our secondary file group, but you need a primary backup there. Always good to have one around. So we'll click OK there. I won't give it a description. You get the point there. And then on the options, same thing here. I'll just leave it as the default. And if you don't back up initialize your media set first time around, you just won't have a name or a description on them. But it'll still initialize everything just with an empty media set name and description. And that's it. So we'll go ahead and choose OK here. And this is pretty much like doing a full backup because we are backing up both the primary and secondary file groups. If we were just to back up that secondary file group, it would have only backed up basically our bug testing.testing table with all the data inside of there. So it would have been a lot zippier than it's going to be. So I'm going to go ahead and pause this for a second. And there we go. Backup is complete. So now we've done every single type of backup known to SQL Server 2005. We've done our full, our differential, our log backups, and our file group backups, and created backup devices. Let's move on to restores. So let me go ahead and open another query up here. Go to open file, we'll open up our restore query that I have. I'm going to cancel and not connect to this. And same with our backup, I'm going to disconnect both of these queries. Because let's say I'm that hacker, and not only have I corrupted your data, but I'm going to go ahead and corrupt your database too. Yeah, that's right. I'm going to come in and go, whoops, no more database. It's gone. I deleted it. Uh-oh, now what? So like I said, the worst kind of hacker, one that'll delete your database and corrupt your data. Yeah, that makes for a lot of work for us database administrators, right? Right. So let's do a restore. How we can do this is we can come right into our databases node, right click on it, choose restore database. So I'll pop open this screen here. And what are we going to restore to? Well, of course, we want to restore to our AdventureWorks database, which isn't in here. So I'm just going to choose our AdventureWorks DW and back that up here. So AdventureWorks, that's what we're restoring to. Where are we restoring from? Well, from a device. What kind of device? A file, and this, of course, your temporary files there, or a backup device. And we're going to go ahead and choose add here. We're only going to restore from our data one initially. And I'm going to click OK. And look at this. Here's both of our backup sets inside of here. We have our full and our differential. So we're actually going to restore from both of these at the same time. Or we'll first do the full and then the differential. So we'll go to options down here. And here's what will happen. There's a couple of options here. And this is what I was talking about earlier. With recovery and with no recovery. What we want to do here is since we want to restore some transaction logs to get it to a certain point in time, we have more restores to do after our full and differential. So I'm going to go ahead and I'm going to say no recovery. Don't let anyone in this database yet. Leave it in a non-recovery state so we can restore additional backups. And this is also what I was talking about with the move option earlier. If you're moving things from company to company, server to server, office to home, from home to office, or office to home, then you can basically just pick your new path. Put your new path right here for all of your data files. Make sure this matches the path that you want to go, because again, it's going to by default choose the path that's stored inside of the backup header. So this is what we want so far. We want it no recovery. We want our full and our differential restored. And I'm going to go ahead and choose OK. So it's going to run through here, and it's first going to restore our full backup, and then it's going to restore our differential backup. And this may take a little bit here, so I'm going to go ahead and pause the video. Be right back. Hey, I'm back. All right, so restore is complete. We'll click OK here, and look at this. Here's our database, but you'll notice it's got a status next to it, a little changed icon. And what this means is it's in the restoring state. Again, it's here. It exists on our server, but nobody can access it yet because we told it not to recover entirely because we're not done. So what we're going to do here is now restore our transaction log. So I'll right click on the database, go to tasks, go to restore. This time we'll choose transaction log, and now we have some more options to do here. Again, we're restoring to our AdventureWorks database. Instead of, again, if you're using those temporary files, it'll try to keep a history and read from the backup history in the actual database. But since we don't have any, we're going to go from file or tape. We'll click on the build button here, go to backup device, choose add, and this time we'll choose our log device. And there we go. And again, you can always view the contents of what's in here every time, which is kind of neat. So there's our transaction log, and click OK. And there it is. There's our transaction log backup with our descriptions and everything about it. Here's also, remember I was talking about those LSNs earlier? Well, they show us. Here's our actual log sequence number of all the items inside of our transaction log, when the last checkpoint LSN was, and really, really good information here. So the next thing we can do is choose a point in time. And also, this is where I was talking about those marked transactions. If you do have any transactions that you're using, again, in long-running stored procedures, and you use marking points, well, it'll actually have all those points in here, and you can choose which transactions you want to basically go up to. But we're going to choose a point in time here. And what point in time do we want to go to? Well, I just happen to know that it was 2:45 and 30 seconds, and after that, everything went bad. So how did I know that? Well, let me just show you this really quick. If we go back to SQL Server Management Studio, what I did, this will be a helpful little troubleshooting tip, is I did a full restore of everything to a temp database. And then I just went into our human resources.shift table and I looked at the modified date and time. And I saw that everything pretty much went bad after 229. This is when our record went in there. And again, it's not always going to be this easy, but you get the gist of it. And by doing something like this, just restoring it to a temp database, you can start analyzing the data to figure out that point in time. You can also query your users and check your event logs. There's lots of things you can do. But just to kind of show you where I was going with that. So we have our point in time discovery. We figured out what point in time that we need to restore up to. We go ahead and choose it. We go to our options, and this time we want to ensure that restore with recovery is on, because this is our last transaction log, our last backup that we're restoring from, so we're ready to make it available to our users again. We click OK, and you can see the transaction log restore very, very quick, and boom, it's done. So we'll click OK here, and let's head on over into our AdventureWorks database, down into our tables, down into our shift table. Let's open this up and make sure that we do not have a Haxword record in there, but we do have our normal and our nocturnal record. Look at that, no problem at all. So transaction log backups, very nice and very handy to save you in situations like that. And you can see our bug testing.testers table is also here that we added after our full backup. So our differential backup caught that, added all 19,000 of our records back in with no problems at all. Now the last one I want to show you is the file group restore. And now there's no easy, quick interface way to do just a secondary online file restore. You have to use code to do this. And it's very simple though. You just simply do a restore database, followed by the name of the database that you're restoring from, followed by the name of the file group. So file group equals bug data. That's the file group we want to restore from our backup device. And there's our backup device, file groups, with no recovery if we have more file groups to restore from. But since we're only going to restore this one, I'm going to take this off of here. I just wanted to show you that that's what you'd use if you did have more file groups you want to restore. And now this is going to be an online operation. This file group will only be down during the restore process. Everything else is functioning great, so only our bug data is going to be down. So if I hit execute here, you see it's going to run through and do the file restore on that file group, only restoring those objects in the database. And as soon as it's done, it'll give us a little information on what happened. Processed 8 pages, successfully processed 8 pages in 8.25 seconds. So that's a file group restore. Not too bad. Pretty simple to do. Again, if you want to do the full restore all of your file groups at once, that you can do through the interface. Just choose the file group option, which file groups you want to restore from in your backup device, and boom, you're on your way. So piecemeal restore is piece of cake. Now the last thing I want to do here is take you through some of these scripts. So what I'm going to do here is I'm going to go ahead and I'm going to disconnect both of our queries from our development environment here, and also disconnect out of Object Explorer for our development environment, and we're just going to connect right up into our production environment here. There we go. And you can see here this is pretty much clean since the last time we touched it, dealing with security. And in our server objects here, we don't have any backup devices. So if we need to add backup devices using transact SQL, very simple, you just use a system store procedure called sp_add_dump_device. And it has a couple of parameters here. The device type, it's on disk, the device name, and this is the logical name, and then the physical path to the actual device. And it's usually, of course, a .bak file, and this will hold all of your backups. So we'll get all 3 of these in here. We'll highlight this. We'll go ahead and click reconnect here. And this time we're going to connect to our production instance. And click connect. And hit execute. And again, you have to be in the master database to add devices such as this. And there we go. So now we hide our results pane here and refresh our backup devices. Check it out. All 3 backup devices, no problem. Now backing up databases is a very simple process here, and I'm not going to go through all of these and run them because it'll take a while. Instead, what I'm going to do is just kind of walk you through the code here to do this, because we did already do this through the interface. Very simple. Backup database, database name to our device name, and then you have some width. Everything after the width is pretty much your options width, and then we give it the name, the description, and then the media name and the media description, since it's our first one, and then also the format and init clause, and that'll go ahead and format the media and initialize it so it can have a backup on it. The next thing we do, of course, we did the bulk inserts. We talked about that. And then we have the differential backup. It's pretty much the exact same thing here. Backup database, the database name to the device name with all of your options. The only difference here is instead of doing all this media stuff, we just use the option differential. And then I'll do a differential backup into that media. And then of course we talked about how to do these inserts and transaction log backups. Transaction log backups, same thing, very simple to do these. Backup, only instead of the keyword database here, we use log. And then instead of backing up our database to our data device, we're backing up to our log device. Same thing though, with our options, name, description, and that's it. And then file groups, pretty simple to do. Same thing, backup database, database name, and then what file group you want to back up, and then to your device. We want to back up to our file group device. And then with name, and then again, all of our options here, pretty much the same thing all around there. Same with our restore. Restore, very, very simple here. Now, since we're dealing with one backup media, you have to choose what file you want to do it, and this is the ordinal of the file in the backup media. So for instance, with our full and our differential, which have their own data device here, as opposed to our log, which also has its own device, with our full and differential, we're just going to say restore database, and it's kind of the opposite. Instead of restoring a database to a device, we're restoring database from a device. So very simple syntax here to get the hang of. And we're saying with file equals 1, and the first file in that backup set was, of course, our full file. And then we're using the no recovery option. We're saying, again, just like in the interface, we have more stuff to restore here, so therefore do not go ahead and make the database available to our users. Same thing with our differential backup. No difference, just that you're restoring a different file. See, the restore process doesn't care what your if it's a full or differential, because it'll figure that out. Same with our restoring our logs here. The first time we restore our log, this is how pretty much we're going to restore our entire log here. File equals 1, no recovery. If you want to restore to a point in time, you have to use the stop at option and tell it what time to stop at. Pretty simple. And again, I showed you here how to deal with file groups. So scripts aren't as scary as they look, really, and they're well documented in books online, so it's very easy to get the hang of doing everything we do in the interface in scripts, because that's all an interface is, right? It's just an interface around transact SQL code. Alright, so in the CBT Nugget, we took a big look at disaster recovery, and I tried to jam a lot into this video because there is a lot to talk about when it comes to disaster recovery, and it is a very important topic. So we started off here with an introduction to backup and recovery. We talked about an overview of backups. We saw what makes up a database, transaction logs and data files, and also file groups, if of course you have a big enough database to do that. And then we talked about the different backups available to us, backup types and recovery models, full differential transaction log for the backup types, and then we took a look at our simple versus full versus bulk logged recovery models. We also took a look at how backup strategies come into play and how we can use those different backup types to form a backup strategy. And then we took a brief overview of what's involved in the recovery process and what options we have available to us when we do recoveries and the different types of recoveries we can do, from point in time to piecemeal restores. And then we got into a huge demo looking at pretty much all of the different types that we can do. We looked at backup devices, pretty much a permanent means of creating a backup device so we can store multiple backups on one device. We took a look at full and differential backups, transaction log backups, file group backups, and then we jumped into the restore process and talked about how we do a restore, the different options that are available to us, point-in-time restores, and of course at the end there we saw piecemeal restores and how we do all of these in the scripting environment. So I hope this has been informative for you, and I thank you for viewing.